Good afternoon, everyone. Welcome. Aluminum recycling is moving from volume to precision. For decades, we melted whatever we got and fixed it in the furnace. Now we're trying to sort it out before it ever gets there. The question is does better sorting actually create more value or just changes who captures it? We've got a full value chain here of recycled materials folks, sortation folks, and alloy production people. We'll do some quick introductions and then we'll move right into some questions. Sam, we'll begin with you.
Afternoon, everyone. Sam Padnos with Lewis Padnos Iron Metal Company, Padnos, fourth generation family owned and operated recycling business focusing on ferrous, non-ferrous, paper, plastics, and electronics. Most recently, we've digging deeper in the pile by focusing on our partnership with Hydro Aluminum, and we have our joint venture Alusort.
Gary.
Actually, no. Gary Gallo, Novelis. I apologize up front. A nasal issue has got me a little off, but hopefully we can get through the rest of this. I work with Novelis Global Metals, and in that role, have been working with Novelis, the aluminum industry, and ReMA to try to develop the end of life of recycling for the product that ReMA helped us to launch last year called Vespa. I've been 40 years in the metals business, first half in steel, the last half in aluminum. Virtually all of that has been in scrap, and the last 12 of those years have been with Novelis. Well, good to be here.
Tao?
Yeah. Good afternoon, everybody. My name is Tao Wang, Global Head of Products and Sustainability with PSW. For those of you who probably not familiar with the company I'm working for, it's a holding company. We have multiple different, very capable recycling facilities around the world. You probably heard of the Triaco Aluminum, which is a part of, our company's portfolio. But being with the company for a year and a half, prior to that, work in the steel industry, Nucor Steel, and then move on to Rio Tinto, and now, steel, aluminum, now working with aluminum and magnesium recycling. So I always joke, I exercise my entire career for the metal lightweighting. So if I go any lighter, I have to work for the carbon fiber, but I don't think carbon fiber is not as sustainable as metal. So I'm pretty happy with where I'm at. Glad and very honored to be on the panel list today.
Doron.
Hi, good afternoon, everyone. I'm Doron Harstein, Commercial Director, IR Metals. Been with the company for 33 years. The company was set up in Israel in 1983 by the late Michael Schwartz. It's a family-run business. We specialize in high-temp alloys, nickel alloys, titaniums, aerospace. More recently, post-COVID, we've been concentrating and investing in sorting technologies, as we see this as the way forward in the scrap metal industry for the foreseeable future.
Thank you. I feel almost badly that I was planning on putting Gary on the hot seat for most of this, but since he's feeling ill, we'll take it a little long, but we'll still begin with you. Gary, what does good mechanically sorted aluminum look like, and how far is most of the market away from that?
So I think, part of the answer to that is going to depend on where you are on the timeline. 20 years ago, Novelis, kind of entered the market with this thing called 3X shred, which was dealer sheet and dealer extrusion shredded, the pieces that we could consume, through our conveyance system and into our furnaces. And at the time, Novelis was buying, or the companies that were consuming that metal were consuming it as taint taper. And what changed was Novelis's need to want to add some density, to the material that went into our furnaces. So we went from bales, we went to the scrap industry and said, can you make this thing called 3X shred, for us, which is where I started with Alumisource, in providing that metal to, Novelis. What changed over the course of the last 20 years, and I think the underlying point from the industry is Novelis's needs, as well as those with many in the industry, have changed. The form has changed, quality specs have changed. When we started with 3X, we didn't think about. We weren't necessarily focused on contamination from things like zinc corners and lead. That eventually evolved to a concern that we solved with technology. And I think that would be one of the messages to underscore here is that if you look at even the downstream history of shredding, initially the polarizer was only designed to do steel, and the non-ferrous fraction was landfilled. And eventually downstream technology came in as the market developed for downstream materials. And we're sitting here today, only a year from last year, where Vesper was adopted by ReMA proactively as a spec to satisfy an ask by the wrought aluminum producers to pull the wrought fraction from Twitch. So if you just said to me 20 years ago, we'd be sitting on stage talking about Vesper, and now its sister product, Ginger. If you told me that's what we'd been doing, I would have introduced you to my shrink and said, you're off your rock. There's no way we've been there. The moral of the story is markets evolve, technology evolves, take advantage of the technology that's in the market and make yourself capable of producing what the industry is ultimately looking for.
Sam, along the same lines, in your partnership with Hydro, has your product ever evolved, and have your specifications changed along the way?
I'd say the products have definitely changed along the way. I think, right now throughput, accuracy, that has been really a core function there. And that's been something that's been maybe, delaying the progression of this business as far as alloy sortation and segregation of material. I'd say really it's been, the big variable is feedstock. You got to make sure you've got a consistent feedstock, to Gary's point, as far as, just the markets. We need to make sure that we actually have a market for material as well consistently. Our partnership with Hydro really helps with that as well. And just working with a team like that, they've got a lot of the metallurgical background as well that can help us meet the various specifications, not only for the billet manufacturing business, but also whether it's the automotive, sheet mills or going into the common alloys as well. So that answers your question there.
Thank you. Tal, you sit in a different position in the market. How do you work with what's available in the market today? And where do you find consistency? Where do you find consistency matters most?
Yeah. So, we talk about the sheet and extrusion. I'm going to bring a little bit a different perspective because we make a lot of, foundry alloy. Right? I'm the easy guy to work with here. Foundry, the foundry alloys, the typical contamination in the routes product world doesn't really matter to us. I probably shouldn't say that too loud, but, my point is, a lot of foundry alloys, the 380s, right, the 356, they have very high content of silica. So there's no amount of silica in the route alloy scrap can ever become a problem for us. So, last year, Triaco did a study and we published on the Netica. If you ever have an interest, come to me, I can share you the study. It pretty much says that 80% of the route alloy scrap can be pulled into the foundry alloy furnace without any sortation, and then came out with a decent chemistry. And before this, we get on the stage, Gary and I were discussing the Vesper that I just learned today. It is a route version of Twitch, right? And then if you talk about the real Twitch is a feeding element into something called A280 for the foundry alloy. That itself tells you how much flexibility we have to work with what's available on the market. But with that being said, do we believe that the best way to unlock the hidden value of the scrap is to sending all the scrap to the foundry guys? Well, as much as I want to say yes, but I can't, right? We believe that the best way to maximize the value is to have sortation precise enough so that, we take the Twitch and separate them to different piles of scrap based on their product types. The casting go to the casting pile, sheet goes to sheet, and extrusion goes to extrusion, so on and so forth. That is the way we think we can maximize the value and, continue to have the consistency for the chemistry and for the quality, moving on the way.
Doron, you bring a really interesting perspective to this panel as you are not a domestic producer in this space. As a recycler in a global market, What are you seeing across across multiple markets, and how consistent are these expectations in your space?
Well, what we understand from where we are situated in the Middle East, we actually have the advantage of being able to ship scrap to the markets from the Far East across to Europe and in a sometimes rare occasion into the US, depending on where the markets are for the grades that are being produced. So, for example, if we have a demand for a low grade mixed tainted bore, then, and the market demand for that in the Far East is firm, there's going to be no incentive to sort, and pull out of a pile of scrap, specific alloys that may be required for individual alloy recycling or remelt. When there is a demand in Europe, usually traditionally for single alloys, then if that demand warrants the sorting, then the effort and the investment will go into sorting technology and even operating the procedures the processes that are available in order to extract those alloys. But if not, we're quite happy to buy, take the bore, cover the costs, add a little bit for the profit, and move it out without having to spend resources in upgrading it.
Doron, we're going to stick with you for a moment. You are also interesting here because you represent sort of the genesis of sortation. You are also heavily in the nickel and titanium space where precision isn't optional. How different is that world from aluminum today?
Well, that's very different because the nickel alloy and let's concentrate on nickel alloy, less so on the titanium. The difference between a mixed or a dirty alloy, or piece of scrap will be, maybe just a small percentage of the full value of a clean alloy once it has been sorted and ready for upgradability for it, which will mean it can go for sandblasting, for shot blasting, it could go for leaching. If it's a dirty material, then it will, or mixed with other alloys, if it could be a aircraft vane with an insert, then that will go into a stainless blend for its nickel points only. And that is very often, when there is a strong demand in the aerospace industry, only half of its real value as an alloy.
Thank you. Let's move on and talk a little bit about economics of precision. Sam, we'll start with you. What are the primary cost drivers when you move into higher precision sorting, and how do you balance throughput versus accuracy?
Great question there. Let's face it, all these equipments, whether you're utilizing X-ray, LIBS technology, optical, I mean, not only is the equipment expensive, the infrastructure around is expensive. So in order to really balance it, obviously having a very robust operations team and also maintenance department as well, just to make sure that you can keep these machines operating. You need to also make sure that your operations team is very financially literate, just because things can change very quickly. Everyone's seeing the current market. You have to be very, very dynamic right now. I would say one thing also is just feedstock availability. When we're talking about new production stampings, whether we're talking about mixed extrusion grades, mixed automotive clips, those are relatively easy to sort with the technology out there. When you start getting into the post-consumer products, it obviously becomes a little bit more of a challenge. But I would say for the most part, when we talk about post-consumer scrap grades there, the X-ray does a very good job as far as just the density separation there. And then the LIBS is really just that precision piece that could really help you there. But aside from the chemistry alone, you also have to take things in consideration as far as what is needed from a pre-treatment standpoint. And also you're going to be running into some issues with maybe some non-metallic attachments there, steel contamination as well. So there's a lot more that goes into it, just, rather than just, hey, what are we going to actually get for a chemistry out of this here? And so that's also something you have to take into consideration from the cost standpoint.
So X-ray is kind of like the hammer and the LIBS is kind of like the scalpel.
You got it.
Well done.
Yeah, thanks. Hey, Gary, here's one for you. As recyclers invest to meet higher and tighter specifications, how should value be shared across the supply chain? One more part of this. And are we actually seeing that happen today?
Yeah. Well, I think as it relates to Vesper, I could make the joke that if Novelis, didn't spend the last 6 months burning down our hot mill in Oswego twice, we'd have been in the market buying a lot more scrap. So right now, there's not a whole lot of value being shared, in this room, as a result of segregating, Vesper from that. Now, that notwithstanding, to your point of how's that shared, at the end of the day, markets are efficient. And if Novelis comes to this room with a spec, or anybody in the optical space, comes to this room with a spec for, Vesper as a product, there is a cost that needs to be recovered, on part of the operators of the equipment. And the consumer is going to need to pay that, value, to all of you. If we're not willing to do that, we're not going to get what we're looking for. So we recognize there needs to be an appropriate return on the investment. This is an evolving market, and I think there's still a lot of question about what exactly, the pricing structure for something like Vesper is. Is the percent of Midwest? Is it Zorb plus some processing? And I think I'm lying if I said that we already had this figured out. We don't. It's still very much, in evolution. And so I think the next, 6 to 9 months will certainly help us to put a final point on that.
Thanks. Tal, from your perspective, does cleaner recycled materials improve your model? And this is sort of 2 parts. Does it ever start to compress your margins? And how do you balance cost versus flexibility?
Yeah, it's a great question. I think if we look at, from the ROI standpoint, right? Where does the sortation create the most value? In my opinion, I'm sure I'm going to take a foundry alloy as another example, but I'm sure the sheet extrusion probably sitting in a very similar situation. In our view, that the sortation absolutely, if I have an imaginary board here, I can draw I'm an engineer background, so I like to do drawings. If I can do a very easy ROI diagram, right? I have a y-axis as a value and x-axis as a effort. Then I would imagine the initial, the ROI will be very high when you start from, the mix of the scrap and you take the Zorba out of the mix and we turn the Zorba into Twitch. All that is a high value, creation period of time. And then as we then you further sort it, you have the Twitch and you sort the Twitch into different groups based on the, product types, the casting, the sheet extrusion. All that, to my opinion, is a very high, value creation period of time. And then, in my opinion, the next boost of the value creation has to come from the chemistry design. So we have to come up with a chemistry, in different products, a sheet, a casting, so on and so forth. Maybe not one, maybe a couple, called a universal chemistry idea, so that each of these flexible chemistries can start to take the mixed alloy, scrap from each individual groups. I know Novelis is working on that. We're working with a lot of OEMs from the casting side. They all have their own version of the universal alloys, basically doing the same thing. The concept of taking these, scraps from each individual groups increase the flexibility, significantly. To me, that's the best way to capture all the values from sortation to a point and then complement that with the, chemistry design. The other part is about the flexibility, right? Where do we stay flexible? Where do we not? Well, it's harder. It's always driven by the application. I always believe that there's the place for each alloy there's a role for each alloy to play in this market. And when we present aluminum as a overall solution. So, and also as a supplier, sometimes I feel like we have the responsibility to understand the application and also pass our knowledge to the customer, sometimes the customer's customer, and show them overall picture of how the scrap will affect not only the chemistry, not only even the raw material cost, but the overall picture of the cost structure. I give you an example really quick. I realize I talked too much. It was a couple years ago. There's a customer coming to us. They want to casting a power door unit. They say, "Oh, we want to use A380 because it's cheaper. Perfect raw material cost drop down. I got a hands, the thumbs up from my boss." We warn them that, the A380 will do a lot of things, but not corrosion. Maybe careful with the corrosion, saying, "No, it's okay. Let's do the prototype." They did the trials and they realized that even though they dropped the cost significantly, we're using a very flexible alloys. They can put a lot of scrap in. That's how they drop the raw material cost. However, they have to put extra steps to put additional coatings on top of that. So I'm using this as an example to show that A380 can do its thing, but not everything. Same thing with the other elements that can do advanced applications, but they may not be able to do some basic stuff. So we as a supplier, we have to, have a deep understanding working with our customers and pass that perspective all the way through the supply chain.
Thank you. Doron, you have the ability again to work across these global markets. Where does this model actually work? And then where does it actually break?
Well, what we see when the end user of the aluminium, someone was putting in an order for a clean alloy, if they have a stable demand and a good premium, then the prices and the investment that will be warranted will be justified. And thus, from the perspective and the point of view of a scrapyard, the areas of the world that will, there's someone anywhere in the world who will buy the material of any type. You just got to make sure that you find the right one who's going to be paying the premium and allowing you to invest in the technology in sorting.
Thanks. Sam, I'm going to spring a question on you. Is precision truly being rewarded in this space, or is it just becoming an expectation?
It's a little bit of both right now, but as far as like the reward for precision, I say yes. And that comes to fruition with just the pricing that you're seeing from consumers. The big thing is to make sure that you've got the various processes and procedures in place, whether it's you're testing your inbound material flows or you're providing that chemistry reports following your production runs just so that you have a known chemistry. That's really important. Let's face it, when we're talking about post-consumer material right now, it takes time. It was, when you get going, it could be a pretty long sales cycle at first. When you're dealing with melt shop managers, casting houses, they're not yet necessarily used to seeing post-consumer scrap. They're used to seeing brand new extrusions or brand new automotive clips or common alloy clips. So sometimes it can take a little bit of time, but the reward is you will see additional value. Additionally, in a long scrap market, where there's plenty of material available, you're going to be one of the first calls. You'll be first in line.
I see. We're going to move on to a section I call contamination in silicon. Now, it is interesting that one of the panelists, Tao, has mentioned that his tolerance for silicon may be different than others, but in many spaces, silicon is a problem. It is a key constraint, and once it's in the melt, it's managed. It's very difficult to remove. So the focus of this shifts the focus of all of this upstream. Gary, what does lower contamination unlock for you and Novelis specifically?
Good question. I think the way to look at that from our perspective is that silicon, unlike Tau, is a killer for us. And what we did best respect, what we knew about the composition of Twitch, specifically the watt fraction of Twitch, was that if we could move all of the ginger from Twitch to create clean Vesper, we knew that the chemical composition would look a lot like 3X would. So the spec that we put into Vesper is a 60 silicon. And there's a question about whether going to a 50 or 40 silicon has incremental value. And clearly, from our perspective, it does. The jury's still out yet because we've been out of the market as to how many producers are capable of getting there and sustaining that production at a 60 or lower silicon at production scale. What we know is that the equipment is there to do that. But clearly, the closer we get to the spec, like alloy to like alloy has more value for us as a producer and is likely to be rewarded, to Sam's point. If you're closer to spec, and beat a spec, we can use some of that metal that has value, to us. So back to the markets are efficient scenario. If that product is created, it will invariably wind up paying for that. And Neil, back to your, is it expected, or is it rewarded conversation?
Okay. Tal, I had a question here written down, but it seems like it's a little relevant. So I'll try to ask the question differently. How much variation can you actually see in your product, knowing that now you can accept some silicon? I think the audience would be interested in knowing more about what it is you guys are looking for.
Well, yes. Oh, well, for silica, it's, like I said, first of all, I'm sitting here thinking, Gary said silica is a killer. Then who introduced silica to this route product? It is us. So, apologize, we just try to follow the basic rule of metallurgy, try to create the fluidity for the casting. Well, but back to your point, back to your question, there are part of the if you remember in the initial paper I quoted at the beginning of this panel, I said that 80% of the material from the raw alloys can be used in the casting world without any further treatment. What about the other 20%? Right? Those are the alloys with a higher magnesium. So your 5182, 5083. So even though silica is not a killer for us, we do have a pinpoint as well. So it's kind of, canceled out each other. You create a magnesium for us, we create a silicon for you guys. So yes, we're looking for a consistency for the magnesium. Okay. So that's one. There is something, the further precise sorting absolutely create a value for the foundry world. That's one point I want to make. The other point I want to make is, even though silica has been traditionally a killer for the route alloys, I know for a fact that working with Novelis, working with a few other partner companies in Aluminum Association, the sheet companies, I'm sure Extrusion is doing very similar work. They have been actively developing chemistries with a high silica. When I say high silica, it's like 3 to 4% of silica. Matter of fact, Constellium, a couple years ago published a paper. It is, that level of silica, 3 to 4% of silica. I know it's still work on the development. It's probably not, commercially readily available, but at least I can see the routes, groups are taking that step, moving ahead and try to find a solution from the chemistry design standpoint so that they can design the chemistry with a high silica, it's advanced high strength aluminum sheet that can not only just take the route alloys with a relatively low silica, but also the casting alloys with relatively high silicon level. So I think, the sortation, working with chemistry design, it will create a holistic solution to generate a high flexibility for us, taking more magnesium, consistent level, and then for the route alloy, take a high silicon with a consistent level. No? Okay.
We don't need you to look at it.
All right. I'm the easy guy to work with.
Doron, from a global perspective, does the market pay for this in your marketplace or simply expect it?
Well, actually, I was thinking when I looked at this question, heard the question, I was thinking that maybe the question ought to be, who should be investing in the technologies? Because ultimately, we've got two parties here, one with a zero silicon tolerance, one with a lower magnesium tolerance, but higher silicon allowance. Where in the hierarchy of the industry should the investment be? Who should be investing in these technologies? Should it be the scrapyards with the risk of no markets for sorted material after they've invested? Or should the investment be from the melters, from the Novelises of this world, etc., who have got a demand which is going to be constant and firm, maybe partnering with some of the great minds of some of the people in the exhibition hall downstairs, some geniuses there who are producing technologies which weren't around last year, definitely weren't around 2 or 3 years ago. It is definitely the future. And as I've always said, the recyclers who adopt the high tech and the AI as the sorting technologies, the first ones who do that will be defining the future of the industry. And despite the challenges being high, it's definitely going to be the way forward for the industry. The question again, who was going to be investing in that process.
Steering away for a few moments from Vespa production over into specific alloy production, specifically like 6s, 5s, and 3s. Tao, how important are rod alloys to your business today, and are you guys buying them?
Yeah, we are. Absolutely. This is a perfect question to a foundry guy. Ask her how important the rod alloy is. As much as I want to say the casting is the ultimate solution to everything, but I can tell you, rod is very, very critical, and it's here to stay. We are buying rod alloy scraps, the 3, the 5, the 6,000 series. They're very nice, great cleanliness, and especially when they're well sorted. It's adding to our furnace and to make beautiful casting chemistries. And then if you ask me, because you see the news, right? People are doing giga casting, mega casting, and say, oh, I can cast the whole car with casting. Well, I don't believe it, because fundamentally, there are 2 reasons. Maybe there are more reasons, but 2 reasons I can think of. One is all the rod alloys surface finish. The beautiful surface that you get from your sheet, you'll get from extrusion. Those that just cannot be simply matched by the casting qualities. Okay. And the other thing is mechanical property. You're not doing the hot rolling, cold rolling, just, for the sake of doing this. You're doing this to generate a very nice microstructure so that ended up having a very nice combination of the strength and the elongation. So for those reasons, this will continue to be made with 3104, 5182, my belief, and maybe some other, variation of the chemistry, but it will always be the sheets. And then if you look at your window frames, the door frames for the building construction standpoint, or the crush management system from the automotive standpoint, it will always, I believe, be extrusion. Extrusion is perfect for those applications. So my point is, when we thinking about the chemistry design, to absorb different format of scraps into the chemistry and make them all work harmoniously, we always have to take the rod alloy into consideration, same thing as a sorting technology. Hope that answers the question.
Thank you. Gary, are you ready for another one? Or are you?
Go for it.
Go for it. Okay. How does the demand for these alloys evolve going forward? And are you guys going to continue to be competitive in the space with this material?
What the answer to that is, we're going to need to be.
Yes, I think that's the answer.
Yeah. Wow. Whatever the alloy is, we're producing, we certainly don't want rod going into cast alloys. So for those of you who are familiar with this, 1% silicon is basically our high water mark. The secondary market can consume virtually all of the rod product consumed. We can consume none of the cast product. So the development of, I think the answer to your question, the development of the alloys for us relative to segregation is going to continue to go down the chain of, like alloy. And in order for us to produce the products that our customers are looking for, whether it's 5182 cam and the cam body, we're going to be better served to make that product with light alloys. And the only thing to get light alloys is, if the industry is willing to pay scrap industry for the amount of work they can get in it.
Try a piece of chewing gum. Maybe that'll pull.
Oh, there we go.
Sam, we'll go to you. Can we consistently recover these materials from mixed streams?
Yeah, if you're saying, hey, can we produce a 3,000, a 5,000, a 6,000 consistently with the technology out there? Absolutely. Whether or not you're using X-ray, AI, optical, you name it, and of course, libs. The technology is out there. The thing it comes back to, again, with post-consumer products is, what's the feedstock you're really consistently, feeding this, because you need to make sure that you've got a consistent source there. If you're, using, I'd say less expensive technology, as long as you've got a very good grasp as far as where your feedstock is, if it's a single source supplier, or if you've got a captive volume essentially that you're processing, exactly where it's coming from. Of course, you can generate these grades pretty consistently without any issue.
Thanks. I'd like to go back to you, Gary, if it's possible, but
Go for it.
okay, we'll do our best. Let's assume we execute this perfectly, and we capture the entire Zorba stream and sort it into usable rod alloys and other casted alloys. Gary, does that satisfy Novelis's need and the domestic aluminum sheet market at large?
So I think, one of the things to look at is if you look at all of the new production capacity that's being installed worldwide for raw product and for cast product, and you look globally, and if you look at the scrap demand that is generated from those new installations, it's widely believed that the aluminum market is going to be somewhere between 1 million metric tons and 3 million metric tons short of scrap. Right? That's a huge, huge number. So one of the differences in that, you perfectly execute this. My colleague here has the ability to use a lot of rod in his product. So of that 3 million tons of additional demand, so that's when it comes from the industry, raw producers are at significant risk of losing inputs to the secondary market because Tao can use almost everything, all the best that you all create. He can consume that. So, if we perfectly execute this, the answer to that is no. We will not, as an industry, meet the scrap demand requirements. And so prime is always going to be, the equalizer in that conversation. Right?
Thank you. Tal, same question to you.
I'm sorry, what was the question?
Essentially, if we're able to capture all the Zorba and sort the rot from the cast, does that close the gap for demand from your perspective in the coming years?
No, not at all. Matter of fact, just like, I'm going to piggyback what Gary said, from the, I realized a lot of audience here for the raw product. So, I used to work for a sheet and extrusion product for a little bit. So I know, it's not going to be enough. No matter how you do the math, it just don't add up. Let me give you a simple example. Casting, sheet, extrusion, they're all the same. So they are generating, some facilities are better than the other, but they all generate about 20 to 40% of scrap. So even if every single piece of scrap is recycled without any loss, then you're still talking about, feeding 100 ton, you're coming back with 40 ton at the best day. And then, what's going to be the rest? Where's the 6 metric ton coming from, right? So that's a gap that we're trying to fill. Okay. So, yeah. So basically to answer the question, one more time, no, it's not going to be enough. Then on top of that, right, with the current technology and with the current chemistry structure, unfortunately, not all the raw scrap is going to go back to the raw manufacturing process, right? A lot of these will be absorbed not only just by us, Gary makes it sound like we can take everything that nobody wants, but, there's also the other die caster out there, the tier ones. And now you see all the OEMs doing the vertical integrations, right? In terms of the whole supply chain, the impact on supply chain, they even have a bigger impact than us. Instead of, in terms of taking the raw alloy scrap and feed that into the furnace and making that into the giga casting, mega casting. So, I'm sorry for a long answer for the question, but simply put, it's not going to be it.
Thank you. I'm going to go back to Gary reluctantly. So inherently that even if we get everything right, we're still short. And so the big question becomes is what's next?
Yeah.
Where do we get the rest of your demand from? Or where's it going to come from? Where do the next innovations come from? Where does Novelis see partnering with this industry or others in order to satiate that demand?
So, just to go back to that, One of the reasons that there will not be enough scrap to meet that demand is the life cycle of aluminum products. So all the installed capacity or the installed capacity that's going into the market today is going to begin to produce products that have a life cycle of 15 or 20 years. So we're going to start making a lot of new stuff, in the next year. We're not going to see that scrap again for 20 years, most of it. So that's if the growth curve for production of continues at this rate, the scrap, the end of the scrap that comes back always tail that. Until the curve flattens or declines, and then the two lines are set. You don't see that happening. So, preventing these things from going to landfill is unquestionably the other major focus for the aluminum industry, and it should be. Vesper upcycles the rock from Twitch. The next biggest chunk of metal that's lost is these things going to landfill. And so I think the opportunities that Novelis is pursuing, looking at how do we partner with those in the scrap and the waste industry to begin to pull UBC and other metallic from places like a transfer station. We're not talking about mining the working face of landfill, but in a metropolitan area, like this, you've got a lot of waste that congregates in a transfer station. Much easier facility to begin looking at the potential of pulling metals out before it goes to landfill. That's not a new concept. 35 years ago, when I was in the steel industry, we talked about doing the same thing, right? But there are advancements, back to the earlier discussion, in technology that I think allow us to recover more of that. I think it's a great opportunity there to partner with ReMA, and solid waste industry to figure out how to make that viable, because we'll never ever hit numbers we need to. These things keep going to landfill.
So that sounds like a commitment to collaborate and utilize recyclers' existing resources to help capture that stream.
From your mouth to God's ear.
Someone write this down. Tao, are there new products or feedstocks that need to be developed in your eyes?
Yeah, absolutely. There's a lot of new products being currently developed. Let me take a few examples here. From the casting world, right? From the casting world, I guess one thing we can do within our control is how do we better utilize the existing casting scrap, so we don't have ever to tap into the raw alloy scrap and make Gary happy. So from that front, there's a lot of development. Like I said, we're working with all the pretty much major OEMs, automotive OEMs around the globe. You talk to every single one of them, they all have their own version of protocol universal alloys. So the universal alloys is created. Well, one example is last year we actually worked with PSW worked with Oak Ridge, and we're Oak Ridge National Lab, and with a few other OEM partners there as well to come up with a rich alloy. You can find there's a press release on that last year, but that is that is sort of an example to showing that how within our industry we are innovating from the chemistry design standpoint, so that this alloy, doesn't look like it's not SO80. It's actually 3 to 5% silica. So if it ever goes back to the raw alloy scrap market, or the scrap, if it ever goes back to the raw product stream, then at least the silica will be lower than the traditional one. That's one. And then it has all the other major elements window wide open. Iron, the manganese, the magnesium, they're all wide open, for the reason that if we can, the reason we designed this is that we can take no matter what casting alloys coming in, blend together, and all we need to do is just add a little bit more silica, maybe not, to meet to the spec. And traditionally, you cannot do this, right? That's when the innovation comes in. We spend a lot of times on the program called ICME, Integrated Computational Material Engineering. That is an AI-backed technology to really accelerate the alloy development. So we're doing all these so that, all the chemistry we put in there, normally when you put the one chemistry at very high extent, it always generates some side effect and reduce your material performance. But the way, the way this alloy is designed is so intelligent that all these elements will kind of work with each other so that one element will suppress the undesirable microstructure induced by the other elements. That's how they work together. Again, without innovation, without ICME, you can never do this with such short time frame. So those are the new technology we're utilizing to make the new product so that the goal is the casting, scrap, staying casting, so we ever have to touch Gary's scrap stream. Hope that answers your question.
Sam, does this push sorting beyond Zorba and other aluminum alloys into other streams and commodities?
I think, the capability, we'll just talk about for Zorba and Twitch and the raw alloy fraction that we could pull out. I mean, absolutely. Now you're producing, various post-consumer products, whether it's a 3,000, 5,000. You can do the segregation to like a more of that lower mag 5,000 or more of a higher mag 5,000. You do a much tighter 6,000, more of like a 63 type of chemistry as well. You can do a little bit more of the harder alloys, whether you're looking at 60, 61 or 6082. So you're seeing this progression take place over time. Now with the technology and the current advancements there, I mean, it's going to eventually go beyond just the aluminum fraction as well. I mean, we very well could do the sortation on just the stainless alloys. We can do it on the, and also on the heavies as well. I think we're already very, very close. The technology's pretty much there, but a little bit more tweaking and refining will get us to, more of the mining of these, various fractions as well. The big thing from the recycling standpoint is you need to be able to take these post-consumer streams and be able to have a big enough toolbox, as long as you're okay with making an investment, in order to be able to handle these and pre-treat these, various products, because it's ever evolving there. And of course, you need to make sure you've got a very good operations team that's financially literate as well and be able to make decisions on the fly pretty quickly.
Thank you. Closed looping is an important concept when it comes to manufacturing as we move forward into the future. Gary, what separates a recycler who gets into your system from one who doesn't? And how do those relationships impact recyclers outside of those partnerships?
I would say that, we talked about this a little bit last year. Novelis is not interested, in diving into the space that all occupied. Sam, and Padnos, supplied Novelis with lots of metal. From our perspective, it's not additive and accretive to the value of Novelis to be able to dive into the space. So the partners that we work with, to do if you define closed loop as, we're buying metal out of the market and we're turning that back into new product. We're always looking for, processors who have the technological capabilities and safety protocols to get to where, we need to go. Had this conversation last night with somebody. In my experience with Novelis as a supplier and now with part of the organization, it's rare that Novelis does not continue a relationship with a processor once we start it. So Padnos usually has been doing processing for Novelis for certainly longer than I've been with the company. And there's a relationship that gets built there. And I have yet to see a processor relationship with, once it's started with Novelis, that necessarily falls apart, but it's based on the ability to, I was talking about in the beginning, to develop and add the various uses of technology to meet our changing needs over time, right? And companies have been able to invest, in that equipment, or become part of the supply chain for Novelis and stay there.
Sam, what still needs to improve before this works at scale?
So, we've got the toolbox. We talked about that, whether the various technologies that's out there. Right now, closed loop, as far as the post-consumer, what it really requires is Obviously, volume concentration is one big one there as well. I'd say there has to be some geographic alignment as well to just the various mills or the rolling mills out there. I'd say, especially in this climate right now with freight costs just continuing to climb there, or else you have to be able to be a little unique and creative with just the various freight opportunities, whether you're putting in baling operations or you're able to just be a little bit creative as far as just the transportation scheme as there as well. And then it's also the big point is really just having contractual structures in place there. I think that's one of the key points there, just because you need to have that market, that consistent outlet. Otherwise, it's going to be preventing the juice won't be worth the squeeze for the recycler.
Sure. Cal, we'll switch over to you. How does closed loop change your access to material?
I think that, first of all, alumina is perfect for closed loop recycling. So we have always, we have already established, no matter if it's our Triaco Aluminum, Agritech, PSW's portfolio company, I have always established this closed loop recycling system for a long time. Like I said, recycling, closed loop recycling is not a new concept that just invented. It's been around for many decades. And, just because of the nature of the aluminum processing, it always comes with, every shot of a casting, every bar of rolling, always comes with a certain percentage of scrap that will naturally go back to the system, right? But what we're seeing here is as people focusing more and more the value of the different type of scraps, and also with the industry slight shift, I'm sure, different part of the product will see different type of vertical integration from the OEM to a different extent. But what we see from our perspective in the foundry world is more and more OEMs are step into the downstream, the casting, the giga casting, the mega casting. That actually opens up our access to even more closed loop recycled material product. And initially, you see, Tesla's been doing giga casting for many years, GM as well. You read the news, Ford and Honda, North America is started doing the high pressure die casting, right? As the OEM started getting more and more involved, first of all, initially they will generate a small amount of scraps, and they probably take that scrap right back to the alloy supplier they've been working with for the decades. But as they scale up, we see a huge opportunity for not only just the legacy alloy supplier, but also the new suppliers to tap into those additional scrap availabilities, because we all know scrap doesn't travel very far, right? So as they building up more capacities, naturally, Sam mentioned the geological locations, they would naturally demand the recyclers to be put their new location around those die casting house. So whoever ready for those type of investments will have a huge opportunity to tap into those new, clean, sometimes well sorted scrap for their supply chain.
Let's change gears a little bit and talk a little bit about what's next. We've kind of been leading up to this conversation. If sortation doesn't fully solve the problem, then what does? What are the next steps that our industry will take? Doron, we're going to start with you. What had to be true in the nickel and titanium markets to support precision, and what lessons can we take and apply to the aluminum space?
That's an interesting question. Titanium, it's a matter of, from this point of view, from a scrapyard again, the supply chain that a scrapyard deals with is a very fluid type of chain where the housekeeping of the suppliers is probably more important than the reliability on the sale. What I'm trying to get to a point, when you've got a contract with aerospace blade manufacturer, the night shift will be turning their swarf and emptying it into the incorrect bin. You've then come to a situation where your pile of scrap that you're buying that's coming into the recycling facility is heavily contaminated. So the concentration needs to be on the good housekeeping policies from your supplier, coupled with a reliable output and market with the customers who are buying the scrap from you once you've sorted it and processed it.
Gary, if you're capable, share with the group. What do you see as the next phases in sortation technology as this thing evolves?
Yeah, I think the way we would look at that is on the investor side, you look at XRT, to your comment earlier, being the hammer. So let's separate what and enter. If we, at the very first of, say, 3 levels, the first thing we can do is segregate cast and rod. We believe that will help us to satisfy that we have for 3x type the market probably has for 3x inputs. The next stage of that, whether it's from XRT, AI, libs, allows you to get to a segregation of 3s, 5s, and 6s as alpha families, and the use of arguably libs to get to the 4-digit alloy separation. The approach that Novelis has taken and what we've suggested to the market is let's not get over our skis on an investment in libs just yet. It's, from Novelis' standpoint, if you can make Vesper with an XRT and it meets our spec, we're good to go. Eventually, we're going to want to upcycle Vesper into automotive alloys. So I want to take a 6016, right? And I want to pull that back into a hood. For that, we know that we're going to need libs to get there. That technology is already well proven. It is proven. The question becomes, what the ability to do that on end-of-life products at scale? 1, and 2, the cost to do that. So is there an equitable ROI for the processor to produce the product that Novelis is looking for? We believe that will be true because eventually going like alloy to like alloy is more efficient for us. Just makes common sense. That's where we kind of have this 3-step program to get from Vesper today as a 3x type input to segregated 6016, 5182 type product that then entails the use of libs to get there.
I want to make sure that we leave enough time for questions, so I'm going to ask one more and I'll allow anyone to answer. What role is AI going to play in all of this? That's the $1 million question of the next generation. I see this all happening. So anyone.
I'm happy to start with that one. I mean, right now, we're using AI in just various aspects of our business right now. But when it comes to actually alloy sortation there, when you're talking about, providing verifiable actual alloys, providing that chemistry documentation as well, we're going to be well on the way. All these machines, they're just gathering a ton of data right now. So being able to actually digest that so that you can actually make it usable information to be able to provide your customers. We're going to get there. And it's not going to be in the next 5 years. It's going to be probably the next year or so. It's coming quick.
Doron, I think you're doing it today, right?
That's correct. Our latest development is an AI-based sorting algorithm with the project that we've been working on is not on this panel, but it's a brass shape sorting with and it's learning as every day. It's learning its shapes. It's learning how a good product should look, what the contaminations look like as well, and it's rejecting them faster and faster. We've had the unit in operation, I think now just over 1 month, and it's nearly doubled its speed and throughput in that time. The future is there. The companies need to invest in staff who will be able to embrace this technology, and they will be able to learn. They'll be able to teach the machinery what it needs to do for this industry. So you're going to need young techies, but you're going to need with the same sort of discipline that our industry traditionally required. It's a little bit of an oxymoron, but it can be found.
Mm-hmm.
Sure. Thank you. Questions from the audience? Come on. No one has questions? We got one over there. Please step up to a microphone if you wouldn't mind.
Yeah, thanks to the comments today. Have you seen our garbage go receipts? I don't know if it's this round. Or if you're yeah, various levels like various abilities as well. And there's it's not a consistency. This is all in the technology.
That's what I was talking about, like where you have to make sure you've got the various pre-treatment, in place, whether you're going to be putting in, additional shredding before you do the sortation or you do screening, prior, let's face it, there's also just surface level contamination. So what are you going to be doing to be able to just handle that? Because like you said, there's various variations there. Most importantly, I would say you need to figure out what you're going to be able to do to get the non-metallic attachments off, as well as just the steel contamination also. It's the technology's there. It's just like, it's up to you to develop your secret sauce there to make it work.
More questions? I don't see anyone running up. I'll ask another one. How does the relationship between recycler and consumer need to evolve from here? Sam, I'm going to start with you.
I think it's really important, just to go and see your customer, there. Not only are you guys going to be having the relationship with the commercial team there, you need to have, deeper levels of relationships as well, just so you actually know the cast house managers. You're able to have those higher level conversations to understand what inputs can they or can they not accept. So that's really and we're seeing a lot of those conversations happening, especially with our relationship with the folks at Hydro as well. I mean, it's fantastic, but I mean, even Novelis, Arconic, Commonwealth, you name it, all these guys, I mean, and gals, they're willing because they know that there's eventually going to be a shortage of scrap. They're going to need to dig deeper into these piles here. So they're willing to have these collaborative conversations here.
They're happening today.
They're happening.
Sal, same question. Do you need me to say it again?
Totally. So I think, first of all, have more ReMA, a panel like this, so we can exchange our ideas. So, I'm actually serious about this because, a lot of times the recyclers and the consumers, they have to understand each other's limits. Okay. Maybe from our design standpoint, if you can just give me a little bit more sorted scrap, that can solve a lot of my headaches. And the other way is if I can open up the spec a little bit more, that can solve a lot of your headaches. So having a constant dialogue between the suppliers and the users, that would bring tremendous amount of value.
Gary, anything to add?
I would actually take Sam's comment and flip it back the other way. And say that a big benefit for Novelis be to have our folks sit in the scrap industry so that when we start sending Vesper into our facilities, people are challenging us on what they see, in terms of particularly the cleanliness of scrap. Most of our operators have no idea where scrap comes from. They have no idea that Vesper used to be, a 79 for Pinto, or, a 2000 Maytag, right? It doesn't occur to them. So for them to be in the yard and see the way your facilities operate, see the way you feed a shredder, what the shredder can do and the product that it makes, and the fact that you can turn a 79 Pinto, into Vesper, is a significant, accomplishment. But we need to go the other way, on that or circularize that same education.
Doron, any comments from your space as you're looking at from a global perspective?
Just from our point of view, the consumer should always allow a sufficient margin to the scrapyard to be able to justify any further investment that is going to be required to meet the demand that we've just seen we're short. And in order to do that, keep the margins healthy. As we often joke in our office, we don't decide anything. Our consumers tell us how much they're going to pay, and our suppliers tell us how much we're going to buy it for. That little gap in between is the one that we have to work on.
Thank you. Any final thoughts from anybody on the panel? None? Any more questions from anyone in the audience? I'm not seeing any. Well, thank you for coming, everyone. We appreciate your time. We hope it was valuable. We'll stick around in case anybody does have any questions they'd like to ask us. Enjoy the rest of your conference.